Good afternoon, Zurich. Today, I have the pleasure of giving you all a short demonstration of this metabolite fingerprinting technique that we use here in our group called REIMS, which is short for Rapid Evaporative Ionization Mass Spectrometry. Now, as you may have heard from the lecture, REIMS is part of a larger class of techniques called ambient ionization mass spectrometry, in which basically the ions or the generation of the detectable compounds happens outside the mass spectrometer, and generally samples are analyzed in their native or unmodified state. Now in the case of REIMS, the ionization happens all the way here, literally 2 meters away from the mass spectrometer on this humble looking metal plate. How is this done? Well, today, considering the topic of our consortium, we're going to demonstrate this with a product that all of us are hopefully familiar with, wheat flour. The sample preparation procedure we developed for wheat flour is simple. Weigh a few grams of flour, mix with an equal amount of a solution of sodium chloride, and then let it rest or stand for 10 minutes. After resting, we are now ready to fingerprint the sample. REIMS generates ions through evaporative ionization, meaning through evaporation. This is typically done here using a diathermic knife such as this one here, which is actually, for those in the know, very similar to the ones that surgeons use when they do surgery. The knife is powered by this power supply here, and you will notice that this other end here is this plastic tube. It is this tube here where generated ions as well as other stuff are sucked all the way to the mass spectrometer through this assembly. The ions are co-infused through this syringe pump here with an isopropanol carrier fluid with a lock mass compound to strengthen the signal and to correct for mass drifts respectively. Excess ions, as well as neutral compounds like those found in smoke, are removed from the room through this exhaust valve. Alright, let's begin. To sample, I simply have to touch this electric knife on the sample and simulate a cutting motion as if I was opening the artery of a patient. The instant that the knife touches the sample, the surface is instantly vaporized and any ions as well as other stuff in the generated smoke are fed to the mass spectrometer. This results in almost real-time recording of the sample's chemical fingerprint. Each sample is usually burned at least 5 times to have a representative fingerprint. After which the fingerprint can be directly read to the custom-made software for classification and discrimination in a few easy steps. Alright, so that's the end of our short demonstration. If you're interested in trying it out for yourself, with a hands-on or with our samples, or maybe if you brought some food samples yourself that you're curious if it will actually work, please feel free to follow my real-world self over there. Hopefully he's sitting over there, and we can see if it works or not. Well, thank you very much, and have a nice day. Bye-bye.